A very good morning to all of you. We are here today to discuss and observe how a traditional programming model works. Unless and until we are very clear about this concept of traditional programming model, it will be improper to start with Java programming. Because Java programming model is fundamentally different than the traditional programming model. Before we get into the model as such, let's reiterate a few facts. First amongst them is that the instruction set that is understood by different processors is different. For example, if you have an Intel microprocessor, then the instruction set understood by that microprocessor might be different than the one understood by, let's say, a Motorola microprocessor, or for that matter, an ARM microprocessor. When I say that the instruction set is different, I don't mean that the addition and the assignment and the multiplication, that would be any different across the processor. That would possibly remain same. But then there are some instructions which might be understood by one processor, might not be understood by another processor. So basically, instruction set understood by one microprocessor is likely to be different than the one understood by other microprocessors. Secondly, when it comes to the operating system level, then the way input-output is done on Windows is again different than the way it is done on Linux, is different than the way it is done on, let's say, Mac operating system. Not only the input-output, even the memory management is going to be different across microprocessors. So one difference is at the microprocessor level, another set of differences, that is I/O and memory management, those differences exist at the operating system level. That is why you have different compilers which are targeted towards a combination of microprocessor and the OS combination. That is why when you visit any site to download a software, it will give you choices. Do you want to download it for Windows, or do you want to download it for Linux, or do you want to download it for Mac OS? Why? Because the compilers are targeted for a OS and the microprocessor combination. This OS and microprocessor combination is often also known as a platform. That's why people say that this compiler works on this particular platform, it doesn't work on other platform. Just to give you an example, Visual Studio would work on Windows and Intel combination. It may not work with Linux and Intel combination. It has been targeted, it has been created by keeping in mind the Windows plus Intel combination. It has not been created keeping in mind the combination of Linux and Intel microprocessor. That is why PowerPoint also works on what? Works on Windows. For Mac there is a different PowerPoint. For Android there is a different PowerPoint. Right? So compilers and applications are targeted for a particular platform. Typical compilers, for example, could be Visual Studio, as I said, would be for Intel and Windows combination, whereas GCC has been implemented for a variety of combinations. That is why you find GCC compiler available for Intex Linux combination. It is also available for Apple and Macintosh combination. Fine. So for different platforms, people target their compilers. The compiler which has been targeted for one platform obviously is not going to work for another platform. Having understood these facts, it's time to understand the traditional programming model. By traditional programming model, what I mean is model that is used or followed by languages like C and C++. Java and Python do not follow this traditional programming model. Their model is different. What is that model? That will come to later on. As of now, let's try to understand in detail the traditional programming model. Suppose we decide to write a C program. Now this C program will be ultimately compiled into machine language instructions for maybe Intel x86 microprocessor. The same C program can be converted into machine language instructions targeted for AMD x86 microprocessor. Or the same C program can be compiled for creating instructions in machine language as understood by the Motorola microprocessor. The instruction set of each of these microprocessors is different. The one understood by Intel may or may not be understood by Motorola, may or may not be understood by AMD microprocessor. So C program is compiled, the same C program, realize that, it will be compiled and targeted towards what? A specific instruction set for a specific microprocessor. And then this machine language code will be executed on, let's say, PC with Windows installed on it. Or the machine language instructions created for AMD x86 may be executed on laptop having Linux operating system on it. Or the program might get executed on Apple with iOS installed on it. What you got to understand is that the exe that is created for Windows will not work on Linux or Mac. Why will it not work? Because the compiler has been targeted to create instructions as understood by Intel x86 and Windows combination. That's why I said it's the platform for which you target the compiler. Program will have to be recompiled if we decide to target it for another platform. What you have to appreciate here is that the program remains same. C program doesn't have to be rewritten again and again and again just because the targeted platform has changed. Means our job of creating a program remains agnostic to which particular platform is that program going to get compiled for. Program remains same. That is why a traditional programming model, people say, is write once, compile anywhere model. What do we mean by this? It means that you are required to write the program only once. But once it has been compiled for a particular platform, that same compiled code will not work on another platform. The machine language instructions created for Intel and Windows combination, those machine language instructions will not work for AMD and Linux combination. Program will have to be recompiled. So program remains same, but compilation will have to be redone the moment the target platform changes. That is why the dictum of traditional programming model is what? You write the program only once, but compile it again and again for different platforms. Once you understood this traditional programming model, it will be interesting to know how Java programming model is different than the traditional programming model. And that is something that we propose to do in the next lecture. Till that time, goodbye, good luck, and thank you.